Hey, that's a really beautiful song, and I want to learn it. I want to know what it means, and I want to be able to sing it. But here's my flashcards. The thing is, I can't read that, not yet, and I don't know how it sounds. And I can turn it around and I can see the words, but to really get the pitch accent and the pronunciation right, I feel like I need to hear it every time I see these words. But normal flashcards aren't doing the job for me, thankfully. So what's our problem? Well, we have a song and we want to convert it to a flashcard deck with audio for each set of lyrics. So we can use something called an Anki flashcard. Anki flashcards are digital flashcards that you can put any HTML on the front and on the back. And since we can put any HTML, we can put audio on them along with text. So that solves the problem of paper cards not having audio. But ideally, we want to be able to do this for many different songs. And creating a flashcard deck in the Anki program manually is a very tedious process. Thankfully, there is a library called GenAnki, which we can use to programmatically create Anki flashcard decks. And if we want to create something programmatically, we need to feed input data into our program. So what input data do we want? Well, we want the lyrics in the native text. In this example, I'm using Japanese, but this program can be used for any language. So here, the hiragana and kanji, and the English romanization, and also the English translation. So those three parts are easy enough to figure out. We can find the lyrics on the internet, some lyric page, and we can find the English romanizations as well as the English translations also on those pages. Or we can translate the song ourselves, translate the lyrics ourselves using tools like Google Translate and DeepL. However, one thing we're still missing is the sound. When we see this, we don't exactly know how it sounds, and you might not know how to pronounce this properly. So hearing the sound of these words on each flashcard can help our mind make that association that helps us match the sound of the song when we're listening to the meaning of the song, as well as the spellings of the words in the song. So altogether, this can help us learn a song and in turn help us learn the language. So how can we send sound data to our program programmatically? Well, we need to know for each card or for each set of lyrics, when does it sound in that song start and when does it end? When are these words spoken from start to finish? And if we can gather for each of these flashcards the timestamps, then we can feed those timestamps into our program and we can clip the song to put that clip in each of these cards. My initial implementation of this project just used its own format. I didn't use any pre-existing standardized format, meaning I just listed the timestamps in with like a dash, this start, dash, the end, and I put lyrics, and I put romanized lyrics, and I put the translations, and then I put a blank space, and then I did that for each card, and I looped through them. And the problem with that is it doesn't allow for the flexibility of using existing subtitles to make these cards faster. Sometimes on YouTube you can find that people have already made subtitles for a song or a movie or for anything, and those subtitles have the start, the end, the words, translations. You can put whatever you want in these subtitles. And so on the second version of the project, I decided to use the .srt format. I described in my README how I used the standardized .srt format, and here you can see how I implemented a specific song. as a .srt file. But we still need to download the song. So we can use the PyTube library for that. It's a non-complicated process. And we need to split that song into each of these parts that are mentioned in the .srt file, which is the format that we're using. And we can use the MoviePy library to make MP3 clips for each card. The most important thing I gained from working on this project, in terms of experience, was getting practice in reading and understanding documentation. There were about four libraries that needed to be used in conjunction with each other, and I had to go from knowing nothing about how to use them to using them specific to my use case. Specifically in the Ankify library, I was following all the documentation, and I still ran into some bug. And the thing about Anki is, Ankify creates a package, and if you load that package into Anki, the program, Anki would give a very non-descriptive error, or so I thought. And so I kept looking back at the documentation, and I couldn't figure out what the issue was. Eventually, I realized that there was a part of the documentation that was shown correctly, but basically you needed the word sound, before the name of your audio clip. And I didn't realize that you needed the words sound, or the colon is a symbol. Before, I thought it was just how the Genenki author chose to describe their audio clip name, but no, it's necessary. So I guess that was a good lesson in following documentation exactly if things aren't working out. And I also got practice a lot with the MoviePy library. MoviePy is a very big library, so to figure out the parts that I needed specifically, just for separating audio into one audio clip into a bunch of little clips and keeping it efficient, was the main challenge of learning to use that section of that library. But I figured it out. And now, the results. Please note there were several features that I didn't mention in this video recording because they're not the core of the project, but they do help a lot with making things easier for the project user.